Hello everyone and welcome to another AP Computer Science lecture. Today's video is going to focus on the creation of methods, in particular static methods, and we'll talk about what that word means. We've seen it in one context, and we'll talk about what it means in that context and what it means in what our goal is going to be. We've seen that we can write code in our main function, and that's create our main method, and that's where the program begins and all our things occur. But sometimes it's useful to take a chunk of code that does something that may be multiple lines and put it under one label. And the main example that we've seen of this is the math library. When we say math.sqrt or math.pow, we don't really see the complexity of what those methods do behind the scenes, right? How is a square root calculated? Do they use the Newton-Raphson method? Do they use some other method? How does POW work? Is it just a simple multiplication, or is it something more advanced? And so the reason they do this is because we don't necessarily need to know the implementation that the Java people chose, but we want to be able to use it as a function, and this is useful. And so we have the ability to create our own functions and label them how we want, determine what their inputs are, determine what the outputs are. And this gives us a lot of control, and as we do this, we kind of switch between two different hats, two different jobs. The designer of the method or the function, who creates how it's going to work, what it does and why it does what it does, and the implementation. And then we can test by being the user. So normally, you may not be both of these things. You might be just the user of function. So for example, we are the user of string methods. We are the users of math methods. But now we're going to be the designers of our own methods, and then we could also use them. Or we could, maybe imagine a scenario where we're professional programmers and we might write methods for other people to use. And that's the kind of goal. Those are the two different hats we'll switch between. And we need to do both because we're students learning and we want to experience both sides, the usage of a method that we wrote and the actual creation of that method. So we're going to do that. In our basics package, we're only going to be in this package a few more times, and so we'll be moving on to new topics soon. We'll make a new Java class, and we'll call it Creating Methods. I think is a good name. Creating Methods. And so there's our class, and I could put a main, but I'm not going to do it just yet, just to show us it's going to be a clean slate when we write our own methods. So I'm going to go ahead and put some notes that we're going to do. So we have the ability to create our own methods. These methods may accept any number of input values and return any type of data we may think is necessary. So we have a lot of flexibility in what we do. So we may not take any input. So for example, the math.random method took no input. It didn't need information to generate whatever it generated, right? The math.pow function needed two inputs, the base and the power to move that base to, right? The square root function took one input, the number to do the square root on. And so as you design your method, you ask yourself, what information does the user of the method need to give us? And this is important because we have to make those decisions, and that may affect how we implement our method. And we could make something more flexible or more rigid depending on what we accept. Excuse me. We might also have to decide what kind of data is given back to the caller of the method. So for example, math.squareroot returns a double, because if we think about square roots, it's very possible that we will not get a whole number answer. Math.pow also returns a double, because even though a base may be a whole number and a power may be a whole number, the reality is they could also put a fractional power or a fractional base, and so we might get a fractional answer, so doubles are a safer choice. And in the math library, there are actually many different functions, and most of them return doubles, but there are occasionally versions of methods that return ints or floats or longs, depending on what we're doing. So if we had to know something that generates a very, very large value, then maybe making something that returns a long could be a reasonable choice. Or it takes longs as inputs. It's up to us how to decide what's appropriate for our goals. And that's one of the keys that we're going to take. Any data type can be returned, and any data type can be an input. This is a big deal. So we can accept doubles, ints, floats, booleans, any of the primitives. We can also accept non-primitives, strings. I mean, we haven't done too many non-primitives, but as we make our own, they can become inputs. So things like scanners, I guess, could be, I mean, it's maybe not that common, but they could be inputs. System.out is a type of thing that we haven't really talked about the details of it, but it's also an object that could be an input. Data types, as we create them and as we use them, are all valid inputs. If it is a valid data type, it is a valid input type and a valid output type. So our method may return a string. And so we'll do several examples that do something like this. So before we begin, let's go ahead and talk about the general structure of our methods. And so what we're going to do is there are two main parts to a method. Two main parts. Method definition. One is the method signature. Right, if you think about what a signature is for a person, it's kind of like a unique representation of their handwriting or of their name that represents them, right? And when it comes to legal documents, you write a signature, you're saying this is me that is agreeing to this, or this is me that is signing this thing. And so a method signature describes the details of the method and how it works. So, and we'll say what it describes specifically. It describes who is allowed to use the method, what the return type of the method is going to be. So what kind of data is it going to give back? The inputs and their types. So any input that might be necessary, whether it's 0 or more, and what their data types are. Right, so in their data types. And the name of the method and the name of the method. Right, so those are several things that are in the signature, and so we're going to talk about each of these. And occasionally there are extra keywords, so, and we'll mention static as one of them in a moment. So some methods use extra keywords, including static. And we'll talk about static in a moment, and we'll see why once we get to that point. So let's go ahead and make a method. I want to make a very simple method. It's going to accept a number, or sorry, accept two numbers, a first number and a second number, and determine if the first number is at least twice as large as the second number. So as an example, if I gave you the numbers 10 and 4, the answer would be true. The first number is at least twice as large as the second. Why? Because 10 is at least greater than or equal to the number 4 times 2, right? Twice as large. So 10 is greater than 8 because 8 is double 4. If I gave the numbers 3 and 9, then it is false because 3 is not at least twice as large as 9. So the order of which you give your values is important. And so if I did 9, 3, then it would be true because 9 is at least twice as large as 3. So depending on what order they give us the input, and we're not going to be strict, we can't control what they give us, we can only control the data type. So let's write our signature. So I'm going to give a kind of general format, and so we'll say something like access modifier. So what is an access modifier? This is the first part I mentioned, who is allowed to use the method. Because as we write methods in classes, we have the ability to decide, can any part of any code use this method, or can only certain parts of certain classes use these methods? And so we're going to stick with one modifier first, and we'll discuss what these mean as we go, and I'll write some more details. And so that we're going to use, this is going to be a keyword, and we're going to use the first one, which means anybody that has awareness of the class can use this method. It's the most loose allotment or allowance of who's going to be able to use it. So that's our access modifier. Who's allowed to use the method? Our return type. Return type. A return type is a data type, a valid data type, primitive or otherwise, that is being returned. One value can be returned only, and it must be of a valid data type. It could be primitive, it could not be primitive, but as long as it's a valid data type. Our method name. So our method name typically should be a unique name, something that gives away what its intent is. So math.pow tells us it's a power function. Math.sqrt tells us the square root function, and so on, right? So the name generally gives away what the intent is going to be. and then a set of parentheses, and we've seen this in how we've used the methods that we've used, whether it was random or math.pow. The parentheses represents the parameter or argument list, the collection of inputs that are necessary for the method to work correctly. And so I'll go ahead and say parameters. And we may have 0 or more, but even if there are no parameters, the parentheses must be included. And so now we can say what is the second part of our method, and this is the method body, where the implementation of the method is written, always encapsulated by a set of braces. Right? So this is what we see, and we've done this already whenever we make our main method, public static void main, we always put a set of curly braces around it. And the class also has a set of curly braces. Curly braces are very obvious signifiers of the chunk of code that we happen to be in. And sometimes they're nested, sometimes they're not, and we'll see that all of our methods must be inside the class that we're in, so they are going to be inside one set of braces, but they'll each have their own set of braces. Right? And so then we can always put our body. So that's the format for the signature. Right? And so let's go ahead and do this. So again, I'm going to write my goal. So goal. Oh, let's do this one. Method goal return true if the first input is at least twice as large as the second input. Both input values will be whole numbers. So as we define our method, describe it, we get to decide as the programmer, I mean the designer. So when we have our designer hat on, we get to decide, well, what is the input? Am I allowing decimal numbers or am I not? And so in this case, my definition, I do not want to include decimal numbers. So I want to write that down. So okay, let's go ahead and write our signature. So here we go. So the access modifier, the first one we're going to learn, and it means that anybody in any class that is aware of this class can use it, and this is the public access modifier, right? So I'm going to go ahead and put a note above it and say public, any class can use this method. Right, so any class that is aware of it, and we'll talk about how we call these methods in a little while, but the idea is that anyone, if this is a public method, any other class can potentially use this method. Right, so all the math, or at least all the visible math methods are public. There might be some that are private, and we might not know what they are and how they work, but all the ones that we are allowed to use are considered public, and that's why we are allowed to use them. This is a matter of security in the language. We can control what code is allowed to do what. Okay. And now our return type, it must be a valid return type. I mentioned that I want to return a true or false, so what would be the best return type? I think Boolean would be a good choice because those are the only possible values, true or false. So let's say Boolean. So there's our return type. Next, we have to put our method name. So the rules for method names are essentially the same rules as variable name. So method name rules, same as method names. Method name standards, same as, oh, sorry, I didn't mean to say same as methods. I said same as variable names. And same thing here, same as variable names. And so what I mean by same is camel case. And generally speaking, we mentioned how camel case, if you include underscores, it's debatable depending on who you ask whether it's standard or not, and it's not important. But generally speaking, Java methods in the standard, at least by the professionals that wrote the language, do not use underscores. It's very, very rare that underscores are used in method names. It's almost non-existent. Right? So camel case. And the same rules apply, meaning that you can't start with the number. You have to start with a letter or an underscore, uppercase or lowercase, and you may contain letters or numbers or things like that. So let's go ahead and put our name. And so again, I'm going to say is twice as large. And so again, when it comes to Boolean names, again, this is not an official thing. It's just a matter of what your style is. And I think usually it's good to kind of write the method name as a question if the answer is a yes or no, right? So I'm asking, is the first number twice as large as the second, right? You don't have to, you can call it twice as big or double big, or you can call it anything you want. But giving a name that's meaningful, I think is always a good choice. And so I think is twice as large expresses that we're asking a question about the inputs. And so now we must put our parameter list, so we need a set of parentheses, and then we ask ourselves, do I need information to make this work correctly? And the answer is yes. How can I decide what is larger than what, or twice as large, if I don't even know what the numbers are? So we need the two values, and so the two values are going to be two whole numbers or int values. So when it comes to our parameters, we use a comma-separated list of variable names. These variable names are temporary and only exist, and we'll talk more about this, but they only exist within the scope of this method. So once the method's done, these variables do not exist. They don't count as if they're in the main, and we'll see some examples of these different things and how accessible they are. So let's go and call it. Let's call it int first and int second. Again, the names are not important, but usually a decent name will give away what the intent is or what they mean. So the first number and the second number. And so notice immediately NetBeans tries to give me an error, and if we hover over it and reread it, we see, go ahead, hover over it, missing return statement. It says, okay, well, in order to make a method, you promised that a Boolean value is going to be given, and I have to have a special line in my method that says, give back a value, and there's going to be a keyword, and the keyword is the word return, and we'll see it in a moment, and it does already kind of spot it for us, saying, hey, you promised Boolean, but you've returned nothing, so please do that. And so we're going to have to make sure at some point we give back a Boolean value. And so we'll make this one very, very easy. Let's make a Boolean variable, so Boolean twice large, and so since we need a Boolean, we're going to make a comparison. And so what am I saying? That is the first one twice as large as the second, or bigger? And so I think that our condition is very simple. We're going to say, is the first one greater than or equal to 2 times the second one, right? So again, if first was 10 and second was 4, is 10 greater than or equal to 8? And the answer is yes. Well, therefore, it is twice as large, right? And so if first was 10 and second was 5, then it would still be true because 10 is greater than or equal to 10. So that's twice as large, right? Maybe a better name, even though it's starting to get long, is at least twice as large. That kind of gives the implicit equal to comparison. Twice as large might suggest that it must be exactly the same. So maybe we should rename it and say is. And this is, I mean, again, Java unfortunately starts to have really long variable names and method names if we want to be really expressive, but it's not that important. So I'm going to say is at least twice as large. I don't claim to be the best method namer or variable namer, but it's definitely something that tends to happen is people have arguments about how expressive, how wordy should you be when writing a method name or a variable name. Okay. And so still we haven't done a return. We haven't officially said the answer is this, give back this answer. But we do have a Boolean answer. And so now the last step is to put the keyword return. And then whatever's next to return, it must be of the type described in the signature. This is like a contract. I've promised a Boolean value. Therefore, whatever is returned better be a Boolean. Now, does it have to be a specific answer? No. Could it be true? Could it be false? If it was int, could it be any integer? Yeah, as long as the type matches. And so in this case, I have a Boolean answer. I must give back a Boolean, so we're going to return whatever is inside of this variable. So twice large. And as soon as we do it, it recognizes, okay, well, you gave me a return statement, and you gave me something that was matching in the data type. So let's go ahead and put a note, right? So return keyword gives back a value to the caller of the method. The value returned must be of the type described in the, let me hide this, I don't really need the output right now, yeah. In the method signature. Right, so we're making a contract, and and the compiler will do its job of enforcing this. Okay, so we've defined a method. We wrote a signature, so who's allowed to use it, what its return type is, its name, and its inputs. We've done some work. This is a very simple implementation, and then we returned an answer that matches that return type. So now we have the designer hat. We've just finished with Contemporary. Let's switch to our user hat, and our user is, in this case, also a programmer, but someone's going to use this method. So let's go ahead and make a main method somewhere. I'm going to go ahead and put it at the top above all of our notes. So I can do the same thing, public static void main string bracket args. And notice, and so we should start to get the hint that main is also a method. That's why I call it the main method or main function. Now, we haven't really talked about what these brackets mean, but we should at least recognize that string is a data type. We haven't talked about the void keyword, but now we see public, so we're saying anybody can use public, and this is super important, because if the main isn't public, the program can't run. Like the program that starts this program, the operating system, Windows or Mac, must have the ability to call this method to begin the program. The Java virtual machine that runs the show has to be able to do that, and so that's why the main must be public. And so we'll talk about static in a moment. We're going to kind of see the problem that's going to occur. And so now that we have this, we can go and let's go ahead and test this out. In our main, let's make two variables. We'll say int num1, and we'll say is equal to 10. Int num2 is equal to 4. Right? That's the example I gave, 10 and 4. And now I want to try to say boolean larger is equal to, and now how do we call the method? We're going to call it the formal way, and we'll see in a moment what's going to have to happen. And we'll also discuss a shorter way to write it in this context. So depending on where the method was made, we have different ways of writing it. But before we can do that, we have to talk about this static keyword. What does it mean, and what is it going to do here, and why are we going to be forced to use it in a moment? And so what I'll do is the primary example, and a great example of the word static, and it has more than one meaning, but when it comes to method definitions, it has a very specific meaning. And it essentially is that there is no context beyond the name of the method and what it is. So static methods that we've been using are basically all the math library methods. Notice we said capital M math, dot something, math.random, math.pow, math.square root, whatever they happen to be. And the reason is because in the context of a square root, the only context is the input. There is no, when we talk about who is calling the method, what object is calling the method, the answer is there is no object calling the method. It's kind of just out there. As opposed to string methods. We saw with dot notation, in a string method, we said some particular string must call these methods, right? Because if you call length, the question that the computer might ask is, well, whose length? Right? Because depending on which particular string is calling the method, there may be a different answer. So if there's a context of an object, of data, beyond the inputs, then that is not a static method. Static methods do not require a context beyond merely the input. And so all the math methods are static. This method we just wrote is going to be static because the reality is there is no thing calling it. This is not tied to extra data. The only data associated with this method is pretty much first and second. They're part of the input, but there's no context behind the scenes. As opposed to a string where the context behind the scenes is all the characters inside that string. And so another example of context-sensitive methods is the scanner. Right? We used the scanner to get input and output in a previous video. And the reality was, the context is, well, which input device are you connected to? Because one scanner might be connected to a file. One scanner might be connected to a keyboard. One scanner might be connected to a database on the internet. And so those are all the contexts. So when you call the method next and next line and next int and next double, they are sensitive to where the connection is being made. They're not just loose and out there. They really do depend on how the scanner was created and what it's connected to. Right? And as opposed to math methods, which they're available. So the bottom line is we use static when we don't want to tie our method to a particular set of data or object. Right? No particular strings, no particular scanners, no particular anything. Just it is available to use. And so in our example, we're going to make this static, and I'll do it on purpose right now. I won't do it just yet. I'm going to try to call the method, and it'll give us an error, and we can read the error and see what it says. Well, main is static because, again, if we think about the idea of what is the context of main, there isn't one. Main is just a special method that begins and does something. And so no one in particular is saying, oh, the main method of a particular object that has data. No, the main is just the loose kind of beginning functionality. It's a procedure or routine or subroutine or method or function. Those are all kind of synonyms for the same idea. And there is no larger context. So static is useful, and we're going to be seeing that in a moment. So let's kind of call the method. We'll see it'll fail, and we'll get an error. The name of my method is at least twice as large. Which is a super long name. Is at least twice as large. And the inputs were two numbers. So I'm going to say num1 num2. And the reason that I can tell this is a problem, NetBeans is not auto-completing because it doesn't officially recognize it because it is not static. And so let's read that error. A non-static method is at least twice as large, int, cannot be referenced from a static context. It says, look, this is a static method, and it's calling another static method, or it's attempting to call a method that is not static. You can't just call it loosely. And so the solution is to force it or to allow the computer to recognize that this method is kind of on its own. It's not tied to anything beyond the class. So we're going to add the word static in front of the word Boolean. Typically, you put an extra method in front of the return type, right? So maybe now I can change my format a little bit and maybe put in brackets, so this is optional, static, right? And so static says maybe this is a loose method or not. And so again, it's a pretty big idea, so it's hard to write a one-liner that expresses what it means, but let's go ahead and try mentioning something like static keyword allows a method to be called without the context of an object with data. Objects are combinations of data and behavior. Static methods are, we'll call it free behaviors. They're just on their own, right? We call them behaviors, we call them methods. Functions is a better name, but the idea is that they're not tied to any context, right? And again, it's hard to describe, but we'll see more and more of this, and when it's appropriate to make a static method, when it's not, and it becomes easier as we go along. But for what we're doing now, many of them will be static methods, right? But it is definitely a challenging concept. And now, notice there's no more error. Now, what I'll mention, this is not the best way to call it. Right? This only works in this fashion with just using the name because we're in the same class. So if you want to make a more consistent way to call methods, it's the way we did the math one. Right? What was math? Math was the class where their code for those methods was written in. So we should call the class name. So instead of saying math.something, we're going to say whatever the class name is dot the method. And in this case, what class is this method in? The answer is the creating methods class. So as ugly as this is going to be, it's going to get even longer. We're going to say creating methods dot, and there it is. So the static context, which is not really a context, but just who controls this method, who owns it, who has it internally, and the answer is the creating methods class. And then dot. So we're technically still using dot notation. The difference is that this dot notation doesn't have an object here, like a variable. It has the class name. Right? And then the name of the method and its inputs. And so we'll see that we'll come back to strings and we'll notice how they're a little bit different. And so now let's go ahead and print out the value. So we're going to say system.out and we'll say first number at least twice as large as the second. And then we'll go ahead and attach larger, which is a Boolean result. So it's going to say true or false. And so here we go. In this example, hopefully, if we did it right, we should get true. So I'm going to run it. And our output should be building, and it'll pop up in a moment. And the answer is true. 10 is at least twice as large as 4, right? Because 4 times 2 is 8, and it is bigger than 8, or equal to 8. So let's do the same thing. Let's do 5. And let's run it, and we should get true again. And there it is. And now let's do 6. Now 10 is not at least twice as large as 6 because twice of 6 would be 12. So we should get false as an answer. And there it is. Now again, you might ask, for this example, it is a very silly, simple functionality. It's literally one line. It's a single comparison. But you can imagine that depending on what you're trying to do, you might have a lot of complex code. You might not want to do it. And the real advantage is instead of having to write this line again and again, and again, this is only one line, so it is very kind of arbitrary, but once we make methods that are more complex, instead of having to copy and paste that code many, many times, we can just use the method every time, right? Imagine if we knew the implementation of square root. We use the Newton-Raphson method, and that might be 100 lines of code to work properly. We call the square root of 1. We call Newton-Raphson. We do all the code for that for one number, and now they give us another number. Are we going to write the same 100 lines again? Again and again and again? No, the idea is that once we write it once and we label it, with the method name, we can call the method and it does the same code. The program actually, we're starting to see that our program, this illusion of going in number order is not really true anymore. What's going to happen is the program's going to begin on line 7, it's going to go to line 9 and 10, it's going to give these values, it's going to hit line 12, and it's going to jump immediately to line 42. It'll do line 42, it'll go to line 48, it'll return the value, it'll come back to line 12, it'll assign the value, and then it'll go to line 13. And so suddenly we're going to be hopping around into different contexts as we call our methods. And this was already happening, but we may have been kind of hiding from it. Okay, so I'm going to stop the video here. This has been a little bit of a longer video. We will do some more examples in the next video. So I hope that we can talk, and we won't have to talk so much about this stuff if we're aware of these things. And so we'll try 2 more examples that I think will be good for us. So I'll see you in the next video.